then I'm going to start recording. This lecture is being recorded. It is continuation with the part 1 of chapter 14. Okay. So part 1, we end up with this amortization table. Make sure you understand each and every number in this table. Okay. So for example, if I ask you, hey, how did you get the principal portion 466 in payment period 6? How did you get this number? The answer is you use monthly payment, $598.66 minus the interest portion, 132.47. You get the principal portion. Okay. If I further ask you, hey, how did you get this interest portion for payment 6? How did you get $132.47? The answer is you use the previous outstanding principal balance, $22,709 times interest, 7% over 12 is the interest. You get this interest portion. Okay, so make sure you understand each number, especially the first two payments, because we did detailed calculations. How did you get PMT? How did you get interest portion? How did you get principal portion? How did you get outstanding principal balance? We did each and every number here. Okay. So this is this table. Okay. The last payment is computed by the same method. Okay. The balance after in this example, remember total number of payment is 48. Okay. The balance after 47th payment is 594. So the interest for the 48th payment, using this number times interest rate, you get just $3.47. Okay. Those are the general equations for amortization table. So how do you calculate the interest amount? It is outstanding balance times periodic interest. In this example, periodic interest is 7% divided 12. That is periodic interest. How do you calculate principal repaid? It is PMT minus the principal, PMT minus the interest amount, and the outstanding balance at the end of the interval equal to beginning balance minus principal repaid. So for example, how did you get this 24,091.71? How do you get this outstanding principal balance? You use the previous principal balance. This number is the previous principal balance minus the principal paid. Okay. So this is the general formula. Okay, this one is about calculating the outstanding principal balance. So often the bank needs to know the outstanding balance or the interest paid in a period before the loan is fully repaid. So before the loan is fully repaid, the bank needs to know what is the outstanding balance or what is the interest paid. The outstanding balance and interest paid can be determined by checking the amortization schedule or by direct mathematical computation. So for outstanding principal balance, there are two methods. Outstanding principal balance. Two methods. Method 1, retrospective method. Retrospective means you go back. When the original amount is known, the final payment has a different value than the other payments. Now we need to look back and consider the loan's original balance and the payments that have been made. This method is a retrospective method, looking back. Now, the second method, prospective method, we look forward. When all the payments have the same known value, including the final payment, and we look forward, consider the future perspectives of the date. Okay, so this is just a concept. I need to give you example to illustrate these two methods. So now, those two methods are the means to calculate the outstanding balance. So now we introduce retrospective method first. So how do I calculate outstanding balance? If you go back, it is just future value of original debt minus future value of payments made. You do two calculations. One, what is the future value of original debt? Two, what is the future value of the payments made? The difference is the outstanding balance. This method is retrospective method. To help you understand this formula, this is just my understanding, okay? I give you an example. If I borrowed $10 from you, I borrowed $10 from you, I paid you $8 already. What is the outstanding balance? You are going to say, hey, 10 minus 8. That is outstanding balance, $2 left. This is this formula. This is my help you understanding this formula. Okay, original, I borrowed you $10. I paid you $8 already. How much outstanding balance left? $2. So let's take a look at example. To buy a car, J borrowed $25,000. That borrowed this loan charged 7% compounded monthly. that he agreed to pay over 4 years. The question is, calculate the outstanding balance after 44 payments have been made. If you can do 44 payments, you can do 31 payments, you can do 45 payments, you can do 25 payments. So this is just example. After this example, you would be able to calculate any outstanding balance after any payments, after 5 payments, after 8 payments, after 16 payments, etc. Okay. So how we are going to do this? We use retrospective method. What is retrospective method? It is said outstanding balance equal to future value of the original loan after 44 periods minus future value of the 44 payments made. We need to do 2 future values. 2 future values. Okay. And then, so how do we do the first future value? Future value of the original loan after 44 periods. This is just a regular compound problem. The future value of original date after 44 periods. Okay, so the formula we use is FV equal to PV times 1 plus I. I heard question. I'll check my question. Okay, in 1 second. So what is the question here? It is already shared. Is this chapter 14.12? No, this is still 14.1. 14.1. Okay. Thank you for your question. So this is the formula for original date after 44 periods, future value of original date. And then we need to calculate future value of the 44 payments. So this is the future value of annuity. Okay, so I'm going to add a note here. Oops. So this one is the annuity, the future value of annuity. And this future value, there are 2 future values here. The first one is just a regular future value equal to PV times 1 plus I raised to power n. The second future value is the future value of annuity. Okay. You do the difference, you get the outstanding balance. Okay. Future value of 44 payments. So outstanding balance after 44 payments is this one here. You can use a calculator to do both these 2 future values. So let me use the calculator. So I'm going to go back to the original question. Okay, so I'm going to use calculator to calculate what is the outstanding balance after 44 payments. Okay. So where is my calculator? Here. So remember, I need to do future value of original date, then I'm going to do future value of annuity. So first, do the future value of original date. Future value of original date. So future value of original date. So I'm going to make some annotation here. So interest is compounded monthly. CY equal to 12. And you make payment every month. PY equal to 12. Okay. N equal to 4 years times 12, 48. Interest IY is 7, obviously. When you use calculator, 7 is IY. So now I'm going to do future value of the original date. Future value of original date. So second equate. Second PY. PY is 12. Down arrow key. CY is 12. Second equate. 25,000. This is a PV. 0 is PMT. When you do this formula, okay, when you do this formula, PV is 0. 7 is IY. 7 is IY. And 48 is N. Compute future value. So you get this number. Okay. You get this number. I'm going to store. Let's see if this number. I'm going to store this number here. So I calculated future value of original date. Let's check with the calculator method. Future value of original date is this number here. After 40. Sorry. It is 44 periods. Sorry, I have to recognize this is 44 periods. So after 44 periods, so N should be equal to 44. In this case, N equal to 44, not 48. It didn't ask you outstanding balance after 48, after 44. Okay, so I'm going to N equal to 44. 44 is the N. Calculate future value. So now it is 32,291. This number agree with the number we did here. Yeah, see, 32,291. Okay. So we did a calculator method for the future value after 44 periods. Next, we do the future value of the annuity after 44 periods. Okay, future value of the annuity. So I'm going to second equate. Okay, double check PY 12, CY 12, and then future value of the annuity. We already know the monthly payment, 598, 598.66. This is PMT. Okay. And we know 44 is N. 7 is the interest. 0 is the PV, compute, future value. So we get this number, agree with the formula method here. Okay. After this, you do subtraction. The difference between these two numbers is the outstanding balance. Outstanding balance. Okay. So this is this one here. Okay. So when you do this one, just make a note, N equal to 44, not 48, because the question given is after 44 payment. So that is the retrospective method. Retrospective method to do what? To calculate the outstanding balance. Next, we are going to use prospective method to do what? To calculate the outstanding balance. Okay. Objective is the same, different method. Okay. So the formula for prospective is outstanding balance equal to present value of the outstanding payments. Outstanding balance equal to present value of the outstanding payments. That is the prospective method. You don't understand right now, no worries. I haven't given you example yet. So wait for the example, you will understand. So prospective method means we need to calculate the present value of outstanding payments. And those are the present value formula depending on types of annuity. Okay. So this formula, present value equal to the fourth formula here, present value equal to PMT. This one, it is chapter 11, section 2. Chapter 11, section 2. Ordinary simple annuity. Actually, 3, section 3. It is ordinary simple annuity. Ordinary simple annuity. Present value. Ordinary simple. Okay. And this formula, if you have a P, present value, that is chapter 12. Okay. Chapter 12, section 2. Chapter 12, section 2. It is about ordinary general annuity. Ordinary general annuity formula. And then this one is due. Ordinary simple annuity due. This one is due. Ordinary general annuity due. When you have ordinary general means, by the way, ordinary means the keyword ordinary payment is made at the end. Okay. General means number of compounding period for interest not equal to number of payment per year. In this formula, P equal to 1 plus IC raised to power C. C equal to number of compounding period per year, that is CY, over number of payment per year, PY. CY over PY, that is C. Okay. So chapter 14, it is actually a good review for both chapter 11, 12, and 13. Remember, chapter 13 is about annuity due. So this formula, I need to tell you where this formula coming from. This annuity due formula. This one is simple annuity due. Okay. Chapter 13, section 1, simple annuity due. And this formula, chapter 13, section 2, general annuity due. As you can see, wow, in this slide, you have chapter 11, chapter 12, chapter 13. And chapter 14 will use all of this, depending on types of annuity. Okay. So hope you can see the importance of chapter 14. It is build the foundation on chapter 11, chapter 12, chapter 13. So final exam, we are going to focus on chapter 14 and chapter 16. Right. So example. Okay, example. This chapter, chapter 14, may be the most challenging one you have ever met so far. So in other words, chapter 14 is more challenging than chapter 11, chapter 12, and chapter 13, because they build on those 3 chapters and add its new concept, techniques, knowledge. So you go slow. Again, I suggest you redo the examples until you're very comfortable with the examples I am presenting. Then you do my lab questions. So example, Skynet financed an expansion project by agreeing to make a payment of $8,000 at the end of every 3 months for the next 10 years. At the time of the purchase, the money is worth 7.8% compounded annually. So without looking at the questions, let's analyze the given numbers. Make payment means 8,000 is the PMT. And the keyword "and" means this is ordinary annuity. Ordinary annuity. Every 3 months means PY equal to 4. 1 year you make 4 payments. 1 year you make 4 payments. For 10 years, n equal to 10 years multiplied by 4, n equal to 40. (7.8) is IY. Compounded annually, CY equal to 1. Okay, CY equal to 1. So now we read the question. Question 1. Use prospective method. Compute the equivalent loan value. Prospective method. Compute the equivalent loan value. Question 2. Compute the interest portion paid and the principal portion repaid by the 37th payment. Question 3. Construct a partial amortization schedule showing the first 3 payments, the last 4 payments, and the totals. Again, this question is very basic and fundamental in chapter 14. Make sure you know how to do this question deeply, fluently, okay? And then you do questions on my lab. Redo this question. So now to look at question 1, okay? The equivalent loan value using prospective method. We are going to do 2 methods. One is a computer formula. The other is the formula of calculator. Okay, calculator. So we need to calculate C. What is C? C equal to CY over PY. CY is 1, PY is 4. And then we need to calculate P, equivalent rate per payment period. P equal to 1 plus I raised to power C minus 1. And N equal to 10 multiplied by 4, 40. So the read original question again. For next 10 years, the question asks you the equivalent loan value. Okay, equivalent loan value. So we use the PV function. Remember the equivalent loan, outstanding loan, it is just the present value here. So here we use this formula. Chapter 12, section 2, to calculate present value. When we know PMT, we calculated P. Use this formula to calculate present value. Okay. So you plug in the given number. I already showed you the formula. The final answer for present value is this one. All right, this is the formula. Now, how do I use calculator? For calculator, second equate, make sure it is at the end mod. Then set up PY. PY equal to 4. Enter. CY equal to 1. Enter. Second equate. Okay. 8,000 is a negative PMT. And the interest. What is the interest? 7.8 is the interest when you use calculators. Where's my calculator? So this is PMT. 7.8 is IY. 40 is N, and 0 FV. Always remember when you use calculator, you need to enter 4 numbers. So final step, compute PV. See, you get exactly the same number as using the formula. So this is the original loan. Okay. Question 1 and question 2. What is the question 2? The interest portion paid and the principal portion repaid by the 37th payment. Okay. Just double check original question. Compute the interest portion paid and the principal portion repaid by the 27th payment. If you can do 27th, you can do 27th, you can do 15th, you can do any payment. This is just example, 37th payment. Remember, each payment has 2 components, principal portion and interest portion. So this question asks you for the 37th payment, how much goes to interest? How much goes to principal? So this is question 2. Okay. So now we need to analyze because the given is the 27th. By the 27th means after 36. So how many remaining payments? We have 4 remaining payments. 4 remaining payments. What are those 4 remaining? 37, 38, 39, 40. Those are the 4 remaining payments. Okay. And we can calculate the present value. Present value of these 4 remaining payments. Use this formula here. Present value. This is the formula method. So what is the present? After you have 4 remaining payments, the question is what is the present value here? Okay, after the 37th payments made. This is the formula method. And how do you use calculator to get this number? You want to use calculator to get this number. Okay. So you have to go to your calculator. Okay. So second equation, it is still Py equal to 4, Cy equal to 1. Okay. And you need to calculate present value at here. The PV here. So you know the monthly payment, the periodic payment 8,000, negative PMT, interest 7.8 is the interest. 4 is the N, and then 0 is the FV. So compute FPV. See, you get exactly the same number here. Okay. So right after 36 payments, the balance is this amount. This is the balance. Once you have this balance, after 37th payment, once you have this balance, and then you do the principal portion, you do the interest portion. Okay. So interest portion of the 37th payment equal to outstanding balance at the end of 36 payments multiplied by interest. And this interest is 7.8%. Interest is compounded how much? Read original question. Compounded annually. So 7.8% compounded annually. Oh, you have to use a P. Okay, this interest rate. Oops. Because the interest conversion period is not the same as number of payment periods. So you need times P. This number is P. How do you calculate P? P equal to 1 plus I raised to power C minus 1. I equal to 7.8% compounded annually divided by 1. C equal to CY over PY. CY is 1, PY is 4. That is C. Okay. So you can figure out the P. Okay. So P equal to 1 plus 7.8% raised to power C raised to power 1 over 4 minus 1. So I'm going to use Excel to do it easier. Do I have Excel? So I'm going to calculate 1 plus 7.8% raised to power 1 over 4 minus 1. Okay. And this is the result, 0.0189. Now copy. So equal to 0.0189542. So this is P. So this number is P. Okay. So what is the interest portion of the 37th payment? Outstanding balance after 36 payment times equivalent rate of interest. The answer is this one here, interest portion. Remember, how did we get the balance after 36 payment? How did we get balance after 36 payment? We use this method, this formula, and I also use calculator verified. This is the result. Okay. So we did principal portion. I heard questions. Why did you do 40 minus 36? You mean, okay, why we do 36? 40 minus 36? Good question. Let's go back to here. The question asks you, what is the principal portion and the interest portion paid by the 737? By means after the 36 payments. And how many total payments? 40. If you use 40 minus 36, you have 4 remaining payments. This is one way to interpret it. The other way, by the 37th payment, you can count how many remaining. You count 37, 38, 39, 40. So this give you number 4. There are 4 payments remaining. See, I make 1, 2, 3, 4. There are 4 payments remaining. We need this number in order to calculate the present value here. And this present value is the outstanding balance right after 36 payments. Does this answer your question? Why we use 40 minus 36? 36 is based on this 37. Thank you. All right. So we did this interest portion. Once you have the interest portion, principal portion, how do you calculate principal portion? Principal portion, you just use 8,000 minus the interest portion. That is the principal portion for 27th payment. Principal portion. Okay, principal portion. Okay, so that is the question 2. Question 3. Construct a partial amortization schedule showing the first 3 payments, the last 4 payments, and the total. This is a daunting task, I'm telling you, okay? The first 3 payments, the last 4 payments, and the total. Okay. Let me see, okay. So how do you do the first 3 payments? Okay, payment 1, payment 2, payment 3. Okay, so this number is already given, right? Monthly payment. And how do you get this number? Remember the first question, we answered this question. Outstanding principal balance. I will show you. The first question in this example is about outstanding balance. Okay, outstanding balance. You get this number. Okay, you get this number in the first question. Okay, and then how do you calculate interest? Interest portion. You use this number. So this number, how do you calculate this interest portion? Interest portion equal to outstanding balance times interest, 0.05 833, okay, times interest. You get interest portion. Then how do you get the principal portion? You use periodic payment minus the interest portion. You get principal portion. And then how do you get the outstanding balance here? You use original balance, outstanding balance, minus the principal portion. And then you repeat yourself for period 2, period 3. Okay. And after that, how do you do the last 4 payments? Remember in question 2, we did the principal portion and the interest portion of period 37. You can apply same method to do principal portion and interest portion for period 36. And then you repeat yourself for all the last 4 periods. All right. So are there any questions? Any questions? I'm going to